And then we start with the definition of pharmacology. What does it mean to you? Somebody? Yes? The scientific study of drugs and their uses in medicine. So let us put it properly now. Pharmacology is a scientific study of drugs and their uses in medicine. This medicine means both orthodox and what? And traditional. Medicine is medicine anyway. Okay? Now, we said study of drugs and their uses in medicine. So, the next thing we want to look at is the drug. What are drugs? Drugs are chemical. That is one thing you have to know. They are chemical. Right? They are chemical substances. So what do? They interact with biological system. They interact with biological system and change them. They change them. Right? They change them. They can change them bad or good. But what we want to change our biological system to good. Fine. Now, let us now talk about the biological system being changed. What and what can be changed? To start with,
they may cause contrast of muscle.
The muscle can be contracted.
Secretion of glands.
Secretion of glands.
Change of metabolism
Metabolism of tissues.
Metabolism of tissue. What do you understand by that? What is metabolism? Change of metabolism of tissue. Change in metabolism of tissue. What is metabolism? Metabolism is anabolism and catabolism. What is anabolism? Breaking down. And catabolism is building or building up. So what do tissue break down? Glucose? Yes. They break down glucose, carbohydrate, even protein, fat. If you are an athlete, you run. What are you breaking down? Glucose. You are breaking down the storage of glucose, carbohydrate in you. And don't forget, carbohydrate is stored in the body as what? As what? Sugar. In what form? Glycogen. It is formed in carbohydrate is stored in the body as glycogen. By which tissue? Liver stores glucose as glycogen, and whenever you are lack of glucose in the body, the liver will now turn the glycogen back to glucose and it puts it in the blood so that all the tissues, all the cells in the body can get glucose to use for their energy. Okay? So when we say change in metabolism of tissue, you now say, now what can we build? I just mentioned carbohydrate can be, when you break the glucose can be stored as glycogen. So you build up glycogen, you store, right? Then at the same time, the body does not store protein at all. But you can store what? Fat. Those who have a lot of fat and then you understand. they store a lot of fat. And not only that, the body needs a lot of organelles. They build up a lot of protein. Protein, don't forget, I've told you proteins are made from amino acids, right? They build protein from amino acids, and most of the time hormones are protein, enzymes are protein, right? And whether endocrine or it's not endocrine, these hormones are protein. They are all made from amino acids. So that is the catabolism, and you now know that metabolism is catabolism and anabolism, the breaking down and building up of substances in the body. That's what we call metabolism. Right. Now, having known this, that drug is a chemical substances and it interacts with the biological system and change them. Now, we use drugs in various ways. Yes or no?
Yes.
So why is it that when you use the drug for headache, right? When you use a drug for headache, it does not go and cure your diarrhea. Yes. When you use a drug like what do we have for pain? And then another very good drug for pain is empirical, right? When you use it for pain, right? It does not go and cure the diarrhea you have, right? Why? It's because the drugs are very specific. Drugs are what? Specific. Drugs are specific. Drugs are specific. So now let us now talk about the specificity of drugs. Right? If you take a drug, if you take an extra or decoction or tincture now, you drink it, isn't it? Yeah. It gets absorbed, and your blood takes it all over the cell, right? And if that drug is meant for headache, or to cure your eye, or you have cocro in the body for skin infection, if you go there and start to work, yes or no?
Yes.
So how does it do it? The only way it can do it is that it has to act, to react with the tissue. Yes or no? There's no other way. Let's think about it. It has to react with the tissue. Right? It has to react with the tissue. That is, if you remember the definition of the drug, by interacting with biological system. So the tissue is now your biological system. It has to interact with the tissue in such a way that it is only that tissue required that we just take the drug. Okay? What do I mean? They feel together like lock and key. Now, let's just imagine that our drug, the action site, of our drug is this. This is the drug, right?
Yes.
Drug action site. Let's just agree on that. Right? Now, for this drug to go and complement in the tissue must have a receptor site. It must have a bit.
Yes.
When an action is coming, there must be something to receive it. Yes? So let us just imagine we have
Receptor.
this receptor. So if that drug is like that, the receptor will be like this. Do you agree?
Yes.
So, in a form of complementarity or like lock and key, this one will just go inside there and lock in and key together. Do you agree with that?
Yes.
We just key together. Once it has keyed together, of course, don't forget this one is the receptor site. So this one will be in the tissue. Right? Abi?
Yes.
Tissue receptor site. This one will be drug action site. Right? So, having got this, now let us now imagine again that there is another receptor site. There is another receptor site in the tissue, in another tissue. And that one has this. Tell me, can this one key into this one?
No.
This is tissue A.
Tissue B.
Tissue
B.
V. Can this drug work on this one?
No.
It's not possible because it cannot key. Right? It cannot key. It won't key. So that is what I'm trying to say. Once you have a drug like this, it will be looking for a receptor site like this. And once it gets there, it gets key. Right? Now, having known that if you inject a drug into the body now, within the next 1 minute, it will be pumped around your body 3 times, 2 to 3 times. Right? Okay? Now, the first time the drug is pumping, it will pump throughout all the tissue, right? Let us say this tissue that needs this repair or this action is in the leg. I want you to imagine how many blood will go to the leg when heart pumps just once. Very little, isn't it? Yes. Very little, isn't it? Yes. Very, very little. So that actually means that very, very little of the drug will get into the leg at a pump. Right? That little one will kill. Don't forget there are many thousands of this one. Yes. Many thousands of this, and this one will be many as well. So that very little one will just kill into some of those ones. So there is, let us just imagine that in this one you have about 20,000 to be killed before action can start. Okay? So magic performed is only just 5,000. Just 5,000 that is pumped of the drug absorbed, the general drug absorbed. That will, don't forget this one too, when it's absorbed, it will absorb in millions. Right? So now you now know that this one will, before the action can start from here, it will pump about how many times? 4 times. The heart will pump about 4 times. So that at the end of the fourth time, enough drug has already attached to this one. Right? And the action will just start. If it's an action for your muscle to contract, the muscle will contract. If it's an action for a secretion of gland, the gland will start to secrete, right? And so on and so forth. Is it very clear?
Yes.
Now, that one looks so sweet, isn't it? It looks so sweet, but it's not like that every time. Sometimes, receptor sites can be very, very similar. You know, even at home, when you just build a house and you bought a lot of many keys, one can open another one sometimes. Yes or no?
Yes.
This also happens in drugs. Sometimes one will or the other manage to fit into another receptor. Okay? They might be similar to each other. It might manage to fit into the receptor, and that's why we have a lot of side effects sometimes. Right? When you are using a drug specifically for a particular illness, we say that one is our main action. We have the main action. Now, after that main action, any other effect which you don't require, which you don't ask for, but you have it, is what we call the side action. Okay? Note that one. I've told you that drugs are not generally too specific, but they can cause side action as well. Good. Having said that, now, how do we now investigate the effect of drugs on the system? The system is so complicated. Like a human being now, you want to test an action of a drug, it's too complex. You cannot get it initially, you cannot get it specifically and be too sure of whatever you are saying, because other things will come into being. Now, what Magnus did, the first scientist that actually made it possible for us, he removed the intestine of a guinea pig, about 2 to 5 centimeters of it, and mount it outside that, and mount it in the laboratory and use it to test the effect of, to find out the effect of his drug. Now, and that leads us to drug action on isolated tissue, right? And then he mounted the live tissue in a solution which we call ringer. Ringer solution is that solution that adds ionic composition equal to that of the plasma. So he made a solution whose ionic composition is almost equal to that of the plasma, and he mounted the guinea pig ileum on it. Now, we all know that it's not just only ions or whatever is in the plasma that the body or tissue will need. We also need a correct temperature. At a correct temperature, the temperature must be right. And of course, oxygen too must be blown in. So, he put the organ bath in a water bath, right? The organ bath is a small test tube. He put it in a big water bath to control the temperature. and we now blew in oxygen so that the guinea pig ileum inside that test tube can breathe, can have oxygen to breathe. Now, of course, the oxygen is to do what? To break down the glucose so that it can get ATP for its physical action, because it will be contracting and relaxing, contracting and relaxing. It needs a lot of ATP. Now, having done that, he now use acetylcholine, acetylcholine, as I told you before, is a mediator. It's a neurotransmitter. It is confirmed that acetylcholine is responsible for all excitatory actions in the body, and it is present in the brain every time. Now, we have the excitatory action on one side and the inhibitory action on the other side, right? During the day, we are very active. That actually means that our acetylcholine is high. The inhibitory action is a little bit low, but during the night, it is opposite. That means our acetylcholine will be low, and then the inhibitory action will be high. And that is why human beings, they sleep at night. Any human being who does, have you seen a human being who does not sleep at night? No. He is sick. The human being, even when you use the whole day to sleep, you must still sleep at the night. Right? So, having said that, we found out that they made acetylcholine in the laboratory. They made acetylcholine in the laboratory and they diluted it into nanograms, because nanogram is 1/1 into raised to minus power 9. That you can see how little the thing is, right? And that is what we need in the body. So he now got he mounted it into a recorder. This is the water bath, and that is the organ bath, and then that is the guinea pig ileum. At one end, it was anchored, and that was the end that oxygen is being blown in. We have oxygen. On the other hand, they put thread, and there's a lever. So when this one contracts, it will pull on this lever, and this lever now goes into a drum, rotating drum. This is a rotating drum. It will be rotating at very slow speed. So, when it's rotating, you see, when there is no action, you only see a single line. Yes or no? Who is not with me? Now when you now put, of course, don't forget there's a thermostat, and there's a where this one goes in. That's ringer in. That's ringer in, and then this is ringer out. You can put your ringer out. It's in your handout. Okay? So when you now put your acetylcholine inside here, you can see the the thing will contract and it will move up. And when you want to notice it to come down, you watch it, right? You watch it.
Okay.
You watch it, and so on and so forth. Now we are going to stop now. This will be the end of our part 1. So by next week we will continue from where we stopped. Any questions?